Beginning by Dr. Walt Brown, we're going to take a look at continental shelves and salt domes. This will be on page 139. The continental shelves and slopes. The escaping supercritical water expanded and accelerated continuously as it flowed out from under the hydroplates and up through the rupture. Therefore, the plates were increasingly eroded along these paths. The horizontal flow made the plates thinner toward their edges, and the flow up through the rupture eroded more near the top of each edge. Also, the edges of each hydroplate sagged downward because the pressure below the edges was less than the pressure below the center. This eroded the bottom edges even more. Consequently, after the hydroplates settled onto the chamber floor, continental shelves and slopes existed worldwide. Before the flood, much of the supercritical water in the subterranean chamber had migrated into the sponge-like openings shown as blue dots above in the chamber's roof and floor. Blue dots above. All right, those are sponge-like openings. Okay. Once the temperatures in the supercritical water exceeded about 840 degrees Fahrenheit, its dissolved salt precipitated, outsalted as explained on page 137. Therefore, it should not be surprising that low salinity water is found under the seafloor, but most geologists are surprised. During the flood, thick layers of sediments blanketed the granite crust, forming aquifers, permeable sedimentary rocks filled with generally salt-free water. Today, some of those aquifers lie below the continental shelf, which constitutes part of the sea floor. During the flood, thick layers of sediments blanketed the granite crust, forming aquifers, permeable sedimentary layers filled with generally salt-free water. Today, some of those aquifers lie below the continental shelf, which constitutes part of the seafloor. Below the continental shelf. Okay, salt domes. Salt dome. Just as a cork released at the bottom of a swimming pool will float up through the water, wet salt can float up through denser, freshly deposited sediments. A salt dome begins to form when a small part of a wet salt layer rises. Other salt in the layer then flows horizontally and up into a rising plume. If the salt is thick and saturated with water, friction offers little resistance and the salt will continue to feed into its rising plume. The upturned or bowl-shaped layers next to the salt dome can become traps in which oil collects. So understanding salt domes has great economic value. Note, if all the sediments in and above the salt layer had not been loose, freshly deposited and nearly frictionless, saturated with water, there would be no salt dome. So that's In the Beginning by Dr. Walt Brown. You can get that online at hpt.rsr.org.